Hello everyone, welcome back to Learn Math Today. The topic today we are going through is the area and volume of similar planes, figures, and solids. You might be wondering, why do we care about similarity? Well, it turns out that understanding how the measurement change when we scale the object up or when we scale the object down is absolutely important in the real world. Whether you're an architect designing buildings, or maybe you're a chef scaling out your recipe, or when you try to understand why your phone GPS can show you the whole country, or the GPS can zoom into your neighborhood, similarity is at work. The key insight we will explore today is this. When we make similar figures bigger or smaller, different measurements will change at different rates. Linear measurements change directly with our scale factor, but area changes with square of the scale factor and volume change with the cube. This will sound abstract for now, but soon you will understand how powerful this concept is. Let me show you exactly with some examples in real life. Let's start with something delicious baking. Have you ever wondered what happens when restaurants or bakeries want to make a bigger cake? Let's say you want to make a cake that is twice as tall and twice as wide as your original recipe. Here is where it gets interesting. You can't just double all your ingredients, because when you double the height and the width, the volume actually doesn't just double. It actually becomes 8 times bigger. This is because the volume grows with the cube of the linear dimension. So if your scale factor is 2, the volume increases by 2 cubed, which is 2 times 2 times 2 gives you 8. That means you need 8 times as much batter, not just twice as much. Next, let's talk about maps and navigation. Every time you use Google Maps or look at the physical map, you're working with similarity. Maps are just a similar representation of the real places. They have the same shape as the actual terrain, just scaled down. The scale factor tells us the relationship between distances on the map and real distances. For example, if a map has a scale of 1:50,000, that means 1 centimeter on the map represents 50,000 centimeters in real life. That is 500 meters. So when you look two cities that look close to the map, the scale factor helps you figure out how far they are actually apart. And lastly, let's look at architecture and construction. When architects create scale models of building, they're using similarity principle to calculate exactly what they need for the real building. Here's a fascinating example. If an architect builds a model at 1:50 scale, meaning the model is 50 times smaller than the real building, the actual building will need a lot more materials than you think. For example, for surface materials like paint or siding, you will need 50 square, which is 2,500 times more material than what's on the model. For volume materials like concrete, you need 50 cube, which is 125,000 times more. This is why architects need to understand similarity so well. One small calculation error could mean ordering way too little concrete for a skyscraper. The key thing we have to remember here is this. When we scale up or scale down, the area will change by the square of the scale factor and volume will change by the cube of the scale factor.
Smash your maths exams. Download Learn Maths Today for real exam questions and achieve top marks.